Okay, we're going to do another layout of a proof, congruent angle, opposite leg, right triangle. Now, what I want to show you here is, it says right triangle, but there is no right triangle, okay? If you haven't seen video 114 first, I really advise you to do it because this is the identical table and statements and reasons that were in number 114, and I'm using them again from the opposite sides proof to do the congruent angle opposite leg right triangle proof, okay? All right, so we've got our drawing, we've got our proof table, statements on the left, reasons on the right, but for you it would have been blank. We've got our given and the thing we're trying to prove. So we have our drawing, but it's not right triangle, so that's confusing, isn't it? And we're given that we've got triangle ABC and that B is congruent to C, okay? And we need to prove that line segment AB is congruent to BC. So what can we do to this to make it a right triangle? We can bisect it. We can bisect CB at point X, which is also bisecting angle A, right? So now, because we've done that, we've got our given that this is congruent to this, but we can say that AX bisects CB at point X because a line only has one bisector, because it's at the midpoint. There's only one midpoint to a line, right? Now, AX is perpendicular to CB at point X because a perpendicular bisector intersects a line at 90 degrees, right? At a 90-degree angle. So we can say that BXA and AXC are both 90 degrees because perpendicular angles equal 90 degrees. Those are both 90-degree angles right in the center there, right? So what we can do is we can go like this, right? Because they're right angles and right angles are 90 degrees. And now, because of where we're at, saying that both of those are 90 degrees, 5 is the same reason as 4, that they're 90 degrees, we've proven that angles are congruent. We've proven that this angle of this triangle and this angle of this triangle are both congruent. Now in the previous video, we had that these two angles were equal because of substitution, but that was doing opposite sides proof. So now we're deleting that step. So these are the new step number 6. That line AX, the bisector, is congruent to itself because of the reflective property of congruence. So guess what? Now we've proven that this triangle has a corresponding angle that's congruent to this triangle, and now we've proven that they have a side that is also congruent. So now we have an angle and a side in two triangles that are congruent. I hope you see where I'm going with this. So now we can say that triangle BXA, the one on the right, is congruent to the one on the left because of angle side. They told us that this angle was congruent to this one. Now we've proven that this angle was congruent to that one, and now we've shown that this side is congruent to that side. So now we have an angle, and a side that is congruent to the other triangles, angle, and side. If you don't know what that is, please see video 106. For reflexive, see 27. So we've proven that an angle is congruent. They gave us that an angle was congruent, and we've proven that a side is congruent. Okay? So now we say that both triangles are congruent. So we can say that line segment AB is congruent to BC because of the rule of CP/CTC, which is corresponding parts of congruent triangles are congruent. Did that make sense? I hope so. I hope that helps you. Remember, when you're doing a proof, the whole point is to say that A equals B, and because B, then you get C. And because of C, you get D, and now that you have D, you've proven E. That's how it comes down in a nice order, just like this did. Our next video, number 116, is an isosceles bisector proof. And I hope I can explain that to you as well as I did this one. See you later.